This lesson is an introduction to functions, learning what a function is and what a function isn't. Functions are really important in math. One way of thinking of functions is to say that they are like a rule, where each x value will produce only one y value. Now, x value can be represented different ways. It can mean the independent variable, the one that we choose or the one that just happens. It can also be called the input variable. It can also be referred to as domain values. All of those are reference to the same thing. The corresponding values are called y values, if I have x values, dependent values that depend on the independent values, or output that depends on input, or range that comes from domain. All of those wordings and associations are important, so you may want to study those. Now, this rule can be done different ways. I can express the rule with words, an equation, tables of values, order pairs, or graphs. And I'll give you an example of what I mean by that. I could say to you that we take twice a number and add one. That's a word association to produce a number. It suggests that we make a number or a result as an output. So sometimes not all the words are there. It might say gives a result. The equation form would look like this. Twice a number. Well, the number is what we control, or what's independent, or what we input, or an x value. So I often use the letter x to represent the number. Twice a number means multiplication by 2. Add 1, and the implied part suggests equality, and the result is the dependent or y value or output, or y. There's an equation. Now I could make a table of values for this. In a table of values, we always put x first, y second, and write it in a column. Ideally, we choose a few negative and a few positive numbers, such as -1, 0, 1, 2, anything I like, because remember, x is what is independent, or what I choose as an input. I substitute or consider the word description, either one. Let's work from the equation. -1 substituted for x, doubled, that's -2, add 1, gives a result of -1. 0 substituted for x, doubled, add 1, gives 1. And likewise, 1 substituted, 2 substituted will produce 3 and 5 correspondingly. This is a table of values. Now, I can also describe these as an ordered pair. -1, -1, x first, y second, x first, y second, and so on, is a set of ordered pairs. Pairs, 2 of them, order, x first, y second. I can also make a graph to represent this information visually. And that would look something like this. -1, -1. Well, this is the y-axis, this is the x-axis. Let's move this down to make a little more room. -1x, -1y. There's that point plotted. 0, 1. 0 in x, 1 in y. 1, 3. 1 in x, 3 in y, and so on. And we can see that in this case they're lining up as though to make a line. Now, I could have chosen other x values like decimals and fractions and so on. It's just not convenient. But all of the numbers in between here for x can be represented as well. So I'm going to fill this in by connecting the dots with a ruler and putting an arrowhead on the end to represent the idea of keep going beyond these points. So this rule in words, equation, table of values, order pairs, and graph look like these things I've represented here in the red ink. Now, a function can be thought of as like a machine, where input gives output. Here's a link that you can follow, and we can see what happens if we go to this web page. I get something referred to as a function machine on this website, and they've kind of done an interesting cartoony sort of a job of doing that. So this represents the place where I put numbers in. I drag one and move it in, and out comes a result. You can see that 4 substituted in gave 12 out from this machine that takes an input, makes an output. Now, you can theorize about what might be happening. How can I make 4 into 12? Well, there's several different ways, like multiply by 3. add 8, and other ways. Let's substitute 3 in here and see what I get. 3 produces 9. Well, we can see that it's not add 8. Add 8 works here, but add 8 does not work here. Multiplying by 3 works here. Multiplying by 3 also works here. Perhaps it's multiplying by 3. If so, this should produce 6, and it does. What do you think 1 is going to produce? So it would seem, from what we can see here of these 4 ordered pairs, or this table of values, that the function is triple the input to make the output. So this number would be 15, 18, and 21. And we can try new functions and see what we get. So you may want to try following that link and experiment with that a bit. Now, there are some tests that can be used on functions. One of the tests to determine if something's a function is called a vertical line test. What I do is I pass a ruler vertically to represent one x value over a graph. Now, watch where my cursor is moving. What's the x value here? You should be recognizing that x is 1 here all the time. Y takes on different values, but x is always 1. Over here, x is 2 all the time. So you see that by considering a vertical line idea, I'm controlling one input value, or 1x. And our rule for function was 1x leads to one y value. Let's make a graph. Here's a graph. And what I'm going to do is I'm going to imagine passing a ruler through this, a set of vertical lines. And I want to think about how many times is this ruler, or this vertical pass, crossing the graph. Well, in this case, it is a function because I only get the graph crossing at one place. How about this one? Watch now as I imagine a vertical line through here. It passes the graph here. It passes the graph here again. This is a non-function. This has 2 y values for a given x value. 2 different results. That means non-function. It can be called a relation, though. Note that functions are relations, but not all relations are functions. A function is just some general rule connecting input and output, but not a one input to one output rule. That's what's special about functions. There's another test. What could be referred to as the y squared, or the absolute value of y test. These vertical lines are a type of bracket that strip away negative signs. So if an equation has either one of these, then what it's saying is that there are 2 y values associated with each x value. This means it's not a function. Here's an example. What if I said y squared equals 9? Well, I can put either 3 or -3 in and produce a result. So if I said y squared equals x, then if x is 9, y is 3 or -3. This is a non-function. 1x produced 2 y's. There's another idea with the absolute value. If I had said the absolute value of y equaled, let's say 2. Well, y can equal 2 because the absolute value of 2 is 2. Positive values don't change sign. And if I substituted -2 in here, the absolute value of -2 has its sign taken away, so it's +2 and therefore also works. Therefore, I'm getting 2 y values when I relate an absolute value to one value, like any x value. So either one of these, if you ever see them in an equation, they are not functions. That's not going to come up too much in Math 9. Now, one other thing to observe, calculator keys. There are a lot of keys on your calculator that take an input. You punch a number in. That's like an x value. They give you an output. That's kind of like a y value. If one input produces one output, that means they're functions. For example, if I take my calculator and type in something like sine of 30 and push enter, I get a certain numerical output. Only one number, one input made one output. Or let's say I have the square root of 9. My input is 9, my output is 3. These are examples of buttons on the calculator or keys that produce functions. One input makes one output. That's the basic idea of what's happening with a function. So sine of 30 equals a certain number. Depending on the mode that you're in, that may be 0.5 or something else. Another example I did was the root of 9 is the number 3, and so on. These are all functions.